Assalamu alaikum. Today we are going to discuss a NUST past paper that is basically NET. So let's get started. The first question says the number under root n, where n is a prime number, is a natural number, a rational number, an irrational number, or a whole number. Okay. Now you need to understand one thing. If you think about under root n as it is, it would be very difficult or complicated for you. But if you think of under root 2 instead of under root n, because n is a prime number and 2 is also a prime number, so whatever holds for under root 2 would hold for any other prime number as well. Okay. So now think about under root 2 and let's see, is under root 2 a natural number? No, it is not. Under root 2 is not a whole number. It is not an integer, so it is not a natural number. Is it a rational number? Okay, we'll see that. A is not the answer and D is not the answer because clearly under root D is neither an integer nor a whole number. Now we need to think if it's a rational number or an irrational number. Since this past paper has a lot to do with rational and irrational numbers, so I basically have this definition. An irrational number is a number that cannot be expressed as terminating or repeating decimals. For example, under root 2 is an irrational number. So clearly, any surd is an irrational number. So under root 2 is a surd. Under root 2 cannot be written as a fraction. So it is an irrational number. Okay, so you should know that every surd is an irrational number, right? Okay. Let's talk about second question. Every prime number is also rational number, even number, irrational number, multiple of two numbers. Okay, think about prime numbers now. We have 2, 3, 7, and so on. All these are prime numbers, right? Prime number is a number that can be divided by itself and one only. So all these are prime numbers. Every prime number is an integer. It is a positive integer. And if we look at the definition of rational numbers are all numbers that can be written as fractions, terminating decimals, and repeating decimals. Rational numbers include integers. Okay, so clearly 2 is an integer and it is a rational number. And we are talking about prime numbers. 2 is a prime number. Okay, every prime number is a positive integer, so it would be a rational number. Now the hint or the tip is, whenever you have been asked such a question and you know certainly that a, b, c, d, or you know any of the options is the option, certainly do not waste your time in reading the other options, because that is firstly going to waste your time and that would confuse you. So definitely, if you know that 237 or any prime number is a rational number and every rational number is an integer, so this is an integer, this is a rational number, so yes, A would be the option. Okay, all right. So let's talk about the third question. The third question has two ordered pairs that are being added. For ordered pairs, we should know if let's say x1 y1 is our first ordered pair and x2 y2 is our second ordered pair. When they're being added or subtracted, we need to be careful that we work order wise. Okay, so I can only add x1 in x2 and I can only add y1 in y2. Okay, with this reference I know that I can only add a with minus a. So if I add a and minus I would get this, and if I add b with minus b I would get this. So 0 0 is the answer, so a is the answer, right? Okay, let's talk about the fourth question now. Here we have, if z is x minus iota y divided by x plus iota y, now we have entered complex numbers. Then z mod s. Okay. Now this is a complex number, but it is not only a complex number. In fact, it is a fraction where we have complex numbers in denominator and numerator both. Okay, we know that. So let's think of this a plus iota b. Let's say this is a complex number. Z mod would be under root the square of real part and the square of imaginary part. Okay, all right. So this is how we find the Z mod. In our case, this is a fraction. It is a fraction of complex numbers, but we only know how to find Z mod whenever we have one complex number. I mean, it's not a fraction. We do not have any other complex number in denominator. So first we need to work on this, okay? Let's work on this. So Z is x minus iota y divided by x plus iota y. For such questions, you multiply the conjugate of denominator, that is x minus iota y divided by x minus iota y. Mathematically, you can multiply 1 with any number, and this fraction is 1 basically. Whenever you have same number in numerator and denominator, that is 1, okay? So we know that it is mathematically correct. And why are we multiplying the conjugate particularly? You'll get to know that shortly. So numerators are same. That would become x minus iota y whole square. And for denominator, what is the rule? This rule is a minus b into a plus b. That gives a square minus b square. So this is my a and this is my b. A square minus b square. And the other thing which you should know is that iota square is minus 1. Okay. So this is x minus iota y square divided by x square. Iota square is minus 1. So minus into minus is plus y square. We are clear till here. Okay. So we can write it as z equals x plus iota y square minus 2xy iota divided by x square plus y square. Okay, now I will simplify it further. Z equals x square minus y square minus 2xy iota. I can write it like this: x square plus y square divided by x square plus y square. Okay. Now I will apply the mod here. Z mod is square of real part. Real part is x square minus y square divided by x square plus y square. This is the real part. I need to square the real part, so I'll get this, plus I need to square the imaginary part as well. So my imaginary part is minus 2xy divided by x square plus y square whole square. So this would basically become, I can write this like that: x square plus y square, right? With the square, this is also coming under the root. And if I open up x square minus y square whole square, this would be x to the 4 plus y to the 4 minus 2x square y square, and this would be plus 4x square y square, right? Now I need to simplify it further. This equals under root x square, x to the 4, sorry, plus y to the 4 plus 2x square y square. Why? Because this is minus 2, this is 4, so minus 2 plus 4 is 2, divided by x square plus y square only. I have the square here, so I can cancel out with my under root, okay? Only the denominator, not for the numerator. Now, I can see that what is my numerator? Isn't it x square plus y square whole square with under root divided by x square plus y square? And I can cancel it out and I would get 1. So 1 is my answer. Let's see if we have that in our options as well. Oh yes, we do have 1. Okay. So clearly, the thing which you need to understand here is that whenever you come across such a question where you need to find mod, first make z a complex number. Although z is a complex number, but it is a fraction of two complex numbers. Like in the numerator and denominator, you have complex numbers. You need to be very careful to have one complex number only. Okay, how can you do that? You will do that by multiplying the conjugate of denominator, because mathematically you can multiply 1. And why are you multiplying the conjugate? Because you know that you will get this form. You will get this form. And once you have this, you will square your iota, you will get -1, and then clearly iota would be removed from the denominator, and that would become one complex number instead of fraction of two complex numbers, right? So we are done with fourth question as well. Let's talk about the fifth question now. Every recurring or every terminating decimal represents. Let's talk about the definition again. Here we have rational numbers are all numbers that can be written as fractions, terminating decimals, and repeating decimals. So this is what a rational number is, okay? So clearly this would be a rational number, right? Repeating decimals, recurring decimals is the same thing. And this is what we have in the definition of rational numbers. So you should be very careful with such definitions because these things are very important from NET point of view. Okay, let's talk about the sixth question now. What is the conjugate of -6 minus iota? Now, if a plus b iota is a complex number, the conjugate of a plus b iota would be a minus b iota. You need to multiply minus with the imaginary part. Okay, this is the imaginary part. So your real part would stay as it is. You have -6, so clearly b is not the answer because here they have changed the real part as well. This cannot be the answer as well. So A would be the answer. Why? Because -6 minus into minus iota is clearly -6 plus iota. Right? So this would be the answer. Okay. Let's talk about the seventh question now. If Z1 is under root -36, Z2 is under root -25, and Z3 is under root -16, then what is the number Z1, Z2, and Z3? Okay, now let's think about under root -36 here. So we have this in mathematics. I can write it as under root -1, under root 36. This is basically iota because this is complex number and this is 6. Okay, so I can write it as 6 iota. Under root -25 would be 5 iota, and under root -16 would be 4 iota. I need to add them because they're talking about the sum here. 6 iota plus 5 iota plus 4 iota is clearly 15 iota. Okay, so this would be the answer. Okay, all right, let's talk about eighth question now. Okay, here's the eighth question. So it is basically we have a set where it has all x's such that every x is in the form p by q, where p by q belongs to integers and q cannot be 0, okay, because that is an indefinite form. All right, so we have p by q where p and q belong to integers. Now, if something belongs to integers, we know that, let's say, if p is 2, q can also be 2, and this is 1. One might think that, okay, 1, so b would be the answer, but no, b is not the answer because this is only one case. We will have 2 by 3 here, we will have 7 by 8 here. 7 and 8 both are integers, so this is clearly a rational number because we are able to write it in fraction. So it is not an integer, it is not a natural number, it is a rational number because we are able to write it in fraction form. And this is basically the mathematical definition of a rational number. Okay. All right. Let's talk about the ninth question now. The function x comma y. Okay. So basically this is the function where we have y equals 1 by 2 x squared. Okay, let's just plot this function on our graph just so we are able to understand it easily. It is going to be a parabola. So this is y, this is x, and this is y equals 1 by 2 x squared. Is it constant? No, it is not constant. Here it is decreasing, here it is increasing. Constant functions are of this type, right? These are constant functions, so this cannot be a constant function. Is it onto? We'll think about it. Is it one-to-one? We'll think about it. Again, these, none of these. Okay, let's talk about one-to-one first, okay, because we have a clear-cut strategy. You need to apply two tests. Two tests are, first test is horizontal line test and vertical line test. Let's draw a vertical line If our vertical line passes through one point only, it passes the vertical line test. Okay, so this graph has passed the vertical line test, and for 1 to 1 it should pass both vertical and horizontal line tests. Okay, so it should pass both the tests. Let's see, if I plot a horizontal line, it is cutting the graph at 2 points, so it is not passing the horizontal line. This implies that it is not 1 to 1. Okay, it is not 1 to 1. All right, so it is not 1 to 1 as well. Let's see if it is on to or not. Okay, now for on to, we need to know that for 1y we should have 1x only. Okay, I mean you will get many definitions on internet, but I'll write it here. Let's say if it's a b c and this is x y z, this is the domain and this is the range. So if we have such a case where we have 1 b is giving this and another element from the domain is also giving the same uh, element in range, this is not onto. Okay, so here let's say this is -2 and this is 2. This and this is basically corresponding to the same y value, right? F of -2 is equal to f of 2. However, -2 is not equal to 2. So this is not onto. The only definition you need to think of is for if two x's are corresponding to one y, it is not onto. This is how you need to understand. And for 1 to 1, just remember the vertical line test and horizontal line test. Okay, so this is not onto as well. We are only left with D option, so D is the answer, none of these. Okay, okay, it is basically a quadratic function. Okay, now we have this, the function y equals mx plus c. Okay, do not get confused by this part, just think of this part only, mx plus c. Now this is the equation of straight line and c is the intercept, and it is a linear function, so clearly d would be the answer because the power of x here is 1. If it was 2, it would have been quadratic. If it was 3, our answer would have been cubic. And if we only had y equals c, this would have been the answer. But since it is, the power is neither 2, neither it's a constant number, neither the power is 3, so D is the answer. It is a linear function. Okay, D is the answer. Okay, let's talk about the 11th question. An element E belonging to A is said to be identity element with respect to a binary operation on A if for all E belonging to A. Okay, for this, E is the identity element. Okay, so for your reference, just so things you can understand things easily, think of the identity element as 1. Okay, so whenever we have 1, we are multiplying 1 with any number, even if it's in this order. Order does not matter in multiplication. This is what we get. Okay, so what is this? This is E into A. Okay, this is not 0. This is not 0 because this is not the inverse of A. This is the identity element. So this is wrong. Okay, again, this is wrong, right? Uh, Here they have written the identity element. However, we are getting A here. So this cannot be the option. This is the option because whenever you are multiplying identity element with another element, the order does not matter because it is multiplication, and we are going to get A, this element, not the identity element. Neither are we going to get 0 because we are multiplying identity. We're not multiplying A inverse. Okay, all right. And even if we are multiplying A inverse, we get 1 in that case. We don't get 0 in that case. Okay, so 0 is basically for additives, right? Whenever we're talking about addition, in that case, yes, A minus A would be 0, but A into A inverse would be 1, right? Okay, right. So the identity, multiplicative identity is 1 basically. All right. Let's talk about this question now. In a school, there are 150 students. Out of these, 80 students are enrolled for mathematics class. 50 are enrolled for English class, 60 are enrolled for physics class. Okay, so 80 are enrolled for maths class, 50 are enrolled for English class, and 60 are enrolled for physics class. The students who are enrolled for English cannot attend any other class. Okay, but students of mathematics and physics can take two courses at a time. Find the number of students who have taken both physics and maths. First, you need to understand the question. We have 150 students, out of which 80 are taking maths, 50 are taking English, and 60 are taking physics. 50 students of English cannot take any other class. Okay, so we will subtract this 50 directly and we will get 100. Why? Because 50 students are fixed, they can only take one class. We're left with 100, right? Now we know that 80 students are enrolled in maths class, 60 students are enrolled in physics class, and students who are taking maths and physics can take two courses. And total number of students is 150. And when we minus 50, we get 100. Okay. Now let's see how many students do we get from maths and physics. So we get 140. Okay. So we are getting 140, but the options, like the number of students that is possible, is 100 only, right? In this case, it means there are 40 students who are taking physics and maths both, right? So find the number of students who have taken both physics and maths. 40 is the answer. Why? I'll repeat. Okay. So we had 150 students in total, out of which 50 are fixed. 50 are only taking English. So we are left with 100, and 80 plus 60 is 140. So as per our calculation, we should have 140 students other than the English students, but we have 100 only. It means that 40 of them are those who are taking both physics and maths, and we are counting them again. So yes, 40 is that number, right? Okay. Now let's talk about the third question. Okay. The product of the roots of the equation, this is, okay, we need to find the roots and we need to multiply. Okay, so for finding roots, we will use the formula. A is 9, B is -5, and C is -27. Okay, x equals minus b plus minus under root b square minus 4ac divided by 2a. Okay, x is going to be 5 plus minus under root 25 minus 4 into 9 into minus 27 divided by 2 into 9. And other tip for any T is that since you would not be using your calculator, so do not multiply anything at this point. We might be able to cancel it out later. Okay. The questions are designed such that students are able to do them without calculator. Okay. So the two roots are 5 plus under root 25 minus 4 into 9 into minus 27 divided by 2 into 9, and 5 minus the whole thing. So let's just write it again this way. Okay, so because they said that we are going to multiply the two roots. Okay, so first root is 5 plus under root 25 minus 4 into 9 into 27, and this would become plus divided by 2 into 9 multiplied by, right, 5 minus under root 25 plus 4 into 9 into 27 divided by 2 into 9. Now, this is A, this is B, this is A, this is B. If we have A plus B and if we have A minus B, this is going to be A square minus B square. Okay, so 5 square minus under root 25 in plus 4 into 9 into 27 whole square divided by 2 into 2, 4 into 9 into 9. Okay, this would be 25 equals, this is going to cut it. A square would cancel the under root. This is not equals, sorry. Okay, this is minus. Then I'll get 25 into 4 into 9 into 27 divided by 4 into 9 into 9. 25, 25 would be cancelled. And then we have 4 and 4 would be cancelled. 9 and 9 would be cancelled. So we are left with minus 27 divided by 9. That is minus 3. Let's see if we have minus 3. Yes, we do have minus 3. So this is the answer. Okay. Let's talk about the 14th question. The multiplicative inverse of 4 is. Now the multiplicative inverse of A is 1 by A, right? Multiplicative inverse of A is 1 by A because multiplicative of A is A to the minus 1, that is 1 by A. So for 4, it would be 4 to the minus 1, that is 1 by 4. So A is the answer, right? And finally, we have 15th question. That is the last question for today. If f of x is 3 plus x, then okay. Now here we can see that every option has derivative. Let's find the derivative of this function. If f of x is 3 plus x, the derivative of f of x is f dash, it would be 1. Derivative of 3 would be 0 and derivative of x would be 1. So 1, right? So if we have a constant function, we can see that derivative is constant. So if we have 0, 1, 2, 3, any number in x is not going to change the value of derivative or the value of function when function is constant, right? So this means that A option says f dash of 0 is not equal to f dash of 1. No, it would be equal. Why? Because this is constant. Whatever x we have does not matter. This value is going to be same. So this is not the answer. And yes, this is the answer. Okay. So I hope it's clear. Thank you very much. Take care. Allah Hafiz.